Inverse of the cosine function. Does the inverse of cosine function exist? Let's find out with the help of the cosine function. This is the graph of cosine function. We know that if a function is a bijection, which means that it is both 1, 1 and onto, then the function is invertible. First, let us check whether the cosine function is an onto function. As we can see that the range of cosine function is from -1 to 1. So, if we consider any point on y-axis within this range, we can clearly see that there is a corresponding point on the x-axis. So, cosine function is definitely an onto function. Now, let us check whether the cosine function is 1, 1 function. For this, we will use the horizontal line test. Draw a horizontal line passing through the curve of the cosine function. As we can see, the horizontal line intersects the curve at more than one point. This means that for each value on y-axis, there is more than one corresponding value on the x-axis. So, a cosine function cannot be 1, 1 function. And cosine function is not a bijection, so it is not naturally invertible. So, how come we are studying inverse of cosine function when cosine function is not naturally invertible? Confused? Don't be. There is a method by which we can make cosine function invertible, and that is what we are going to discuss now. As of now, we know that cosine function is not naturally invertible because it is not a 1, 1 function. So, we can make it invertible by making it 1, 1 function by restricting its domain, just like we did it for the sine function. Let us understand how we can do this. As we can see that the domain of the cosine function is real numbers, and we know that the cosine function is not a 1, 1 function in this domain. Now consider the interval from 0 to pi. We can see that in this interval, the curve of the cosine function passes through the horizontal line test. This means that the cosine function is 1, 1 within this interval. And we have earlier seen that cosine function is always onto. This means that the cosine function is invertible in this restricted domain. Or in other words, we can say that the inverse of cosine function exists within the restricted domain. Actually, the cosine function is invertible in any of these intervals. So, the inverse of cosine function exists in each of these intervals. The inverse of the cosine function is denoted like this, or it can also be denoted like this. We read it as arc cosine. This means that if y equals to cos x, then x equals to cos inverse y. If we look at the graph of the cosine function, we can see that the range of cosine function is closed interval, which is -1, 1. So the domain of cosine inverse function will be closed interval -1, 1. And the range of cosine inverse function will be each of these intervals because cosine function is invertible in each of these intervals. Corresponding to each of these intervals, we get a branch of function, and out of these branches, the closed interval 0 to pi is known as the principal value branch. Therefore, the range of the cosine inverse function is closed interval 0 to pi. And this is how we write cosine inverse function. Thus, the inverse of cosine function is defined as cos inverse y equals to x if and only if cos x equals to y, where x belongs to the closed interval 0 to pi and y belongs to the closed interval -1, 1. Let us now try to draw the graph of the cosine inverse function. As we know that if y equals to cos x, then x equals to cos inverse y. So the graph of the cosine inverse function can be obtained by interchanging x and y axis of the graph of the cosine function. Thus, the graph of y equals to cos x. By just interchanging the axis, we can draw the graph of y equals to cos inverse x. This shaded portion of the curve from 0 to pi is known as principal value branch. Any value of cos inverse x within this interval is known as principal value of the cosine inverse function.